So, welcome everybody to our next session from our energy management round with the ESG compliancy. You would have expected my colleague Lukas Teilhacker to be here today with me, but he has some other duties to fulfill. That's why Benjamin Gehlken is here with me, our solution architect, and he was in close collaboration with Lukas to prepare this presentation, so that's why he was able to take over at this short notice. So welcome, Benjamin. Good to have you here today. And just one notice from my side, if you have any questions during the presentation, please feel free to put them in the chat window that you have to your right-hand side. And we will get back to your questions after the presentation, our Q&A session. But now I will hand over to Benjamin and have fun with this presentation.
Yes, perfect. Thank you, Gerrit. Also, warm welcome from my side on a sunny day in Hamburg. At least now, we never know what's going on in the afternoon, but so far it has been very good. And yes, as Gerrit said, I'm Benjamin. I'm one of the solution architects here at Cybus in the industrial solutions team. Before I was a solution architect, I was already at Cybus as a partner manager, was in close collaboration with our partners on joint architectures, go-to-market strategies, and as well in joint customer projects. What do? We actually support our sales team with technical expertise during, before, and actually after engagements with the customers, and in the pre-sales phase. So that's not our only responsibility. We are also actually having a close eye on the market and what's going on around the industry, what's maybe affecting our customers or our future customers, and also regarding our product Connectware. That's why we also have this energy monitoring round or ESG round today, because we see that it's for our customers very important to follow environmental goals, also social goals and governance goals. That being said, let us start with the presentation, fast track to ESG compliant energy monitoring. And I would just go and just have a look at the agenda for today. So the topics, it's first, we have a short glimpse on the urgency and the ESG criteria, following the first use case of a customer, how he actually started, or they actually started with energy monitoring. Second use case, it's more a holistic approach on energy efficiency and how to use the whole production. And then after that, we will have a short view on the architectural design, and after that, have a little sum up. So if we talk about the ESG compliance, so environment, social and governance rules or goals, regulations, they are very prominent at the moment. So if we think about the climate change, that's, I mean, I don't have to explain that. Also the governmental regulations in Germany, we have the Energieeffizienzgesetz coming up. We have also investor pressure and fundings, which at the moment are also kind of combined with environmental, social and governmental goals of the companies. And as well, which is, I think also coming more and more is the consumer expectations that companies actually operate sustainably, ethically, and also transparent. But first, let's have a short look at the ESG. What is it actually? So it's consisting out of three goals, let's say. So it's environmental, social, and governance. That's ESG is more a regulation, but there are like many regulations, frameworks, how you can actually comply with this ESG frameworks. And there's like the GRI, Global Reporting Initiative, but there's also the Corporate Sustainability Reporting Directive, which is a CSRD. So you see there are many, and there are also ISO policies you can actually follow and put that into these frameworks as well. So let's short break down what each component means. So the environmental point, the E, is actually the aspect which focuses on companies' impact on the environment, includes factors such as climate change, energy efficiency, resource consumption, waste management, and also pollution. Companies that prioritize eco-friendly practices and they minimize their footprint, and also for that they receive a positive ESG rating, actually. So the social dimension considers a company's relationship with various stakeholders, including employees, customers, suppliers, but also communities, which is also very important. And topics are social criteria like labor conditions and human rights. The governance part relates to how a company is managed and controlled, encompasses aspects like corporate leadership, ethical principles, and transparency, and also board composition. But for now, I would like to just ask a question and quickly get your feedback on actually how your company is complying, or how is the company actually achieving the ESG goals. So did you already start? Are you just getting there, or are you actually actively engaging already, or is it in an advanced state, let's say, in the implementation? So that would be really cool if you could just quickly answer this question for me. That would really helpful. Would be really helpful. As well, I can also teaser if you want to meet us and talk a little bit more about how we actually operate this energy monitoring at our customers. We are also at the HMI next week. We'll come to that at the end of the presentation. So if you want to meet us in person, we are very happy to meet with you and discuss and engage. So there are already some coming in, 7 from 19. Just quickly. So 9. Just getting started is actually on the rise, I would say. So I think they're not coming more. I think we can probably close the poll. And then I can just quickly, I hope you can see the results. So we have not started yet is 1, just getting started is 6, and actively engaging is actually 2. So just getting started, it's also what we see at the moment, is 32% of the 47%, which actually had had some or like put the button or push the button. So, but today, actually in this presentation, we want to focus on the E part, so on the environmental part, as we see that like this energy monitoring case is also very prominent at the moment, as I said, also due to the fact that in 2025, there's the Energieeffizienzgesetz coming in Germany, which also implies that you need to monitor your energy within environmental management system or an energy management system. So they are the ISOs 14001 and 50001. So now is probably also the right time to already prepare for that, to comply with this ESG goals and also with the Energieeffizienzgesetz. So I would say let's dive right into the first energy monitoring use case. As I said, we will have one which is more like focused. So on this use case, our customer actually focused directly on energy monitoring, and then they got a little bit deeper. They identified that their electricity actually is 750,000 megawatt per hour, in a year over there, like more than 100 factories, which was if you see the total consumption of energy and the majority of the energy costs, which lie at like 174 million in a year, which is quite a lot. So they wanted to have a saving in electricity of 7%, and that made actually up an annual saving of 12 million calculated, which is quite a lot if you think that you're just 1 month is 1 million. So if you're not acting now, that's losing 1 million in a month. On that point. So how did they actually start? How did they want to roll out? The step 1 is actually the create step. So create an initial deployment plan, prepare the initial technical rollout plan, define the local IT requirements, firewall servers, create local checklists with IP addresses, the device list. So could be machines, could be sensors, could also be building automation if you want to include that. But they actually quite just focused on the energy part, and then define an initial data model and semantics. So on the next step, it's to refine the deployment plan. So they had a look if they actually were successful, or like within the teams, they actually complied with most of the defined variables. So they did a refined the rollout plan, created already configuration templates, had like a first architecture, how they want to use our product into their architecture, and then finalize the data models and the rollout guidelines. And then in the next step, they actually started to plan the rollout already. So how they want to go into the next factories. They identified reference factories where they first wanted to test the solution, the energy monitoring solution, the architecture, and then actually in step 1, they already started to plan the rollout on a level that it could be implemented. On that part, they started actually to just see which factories are more far in terms of digitalization and also energy monitoring. So they started with focus factories to roll out there and to have a fast factories rolling out the use case, and then also getting these factories on board to then start the rollout for other factories as pilots, and so that they could have like the first movers showing others how they actually did it and how fast they went with the further rollout. And then in step 3, actually, the extension step, it's in the individual factories. That's not yet, so it's starting next year. They want to have other use cases defined, and also they have sometimes already a roadmap with the use cases, and they think about implementing other use cases with the architecture and the data infrastructure they already have in place. So now that was the first use case on like really steep going into the energy monitoring use case. And then we have another example where at first also the energy monitoring use case was very highlighted, and also the building automation was highlighted due to the complex and energy intensive production processes in the battery cell manufacturing area. And what kind of challenges actually does the battery cell production have? On the beginning of the production, they have high scrap rates because it's a new technology, new processes, and to learn from these processes and to get better to reduce the scrap rates, that's also consuming a lot of energy. That's one big challenge. Then energy intensive processes, we will have a look on that in a minute. Then high relevance in building automation. They have processes where they have high temperatures, and so the exhaust air needs to kind of reused or maybe can be reused, but also needs to be measured, like where is that going and how much is it actually, and maybe can we have a process to reuse that. High relevance, strong governmental policies in battery cell production. They're actually on the focus, I would say, with governmental policies as a production, like the battery pass, so the product pass, where you also need to include some other metrics you need to measure from your production. There are also some energy metrics you need to put into that during the production process. And then there's also the technological change in the production, because battery cell production and the battery cell itself, if we think about when they started, it's a rather new process and rather new production. So there will come in the next years a lot of technological change within the production. So they also need to be flexible on that point. Putting that all together, it's a really complex production. Maybe also like automotive, it's complex. But if we think about automotive, that's here for a long time already, also in Germany and in the world. So that needs to develop as well. Let's have a short look on how batteries are actually produced. We start with the electrode production. So there's a mixing process where anode and cathode recipes go together. That is then coming to called slurry. So a paste maybe to call it like that, but it's called slurry. Then it gets coated on a copper foil. It's a wet process. So after that, actually, you need to dry. It's evaporating. So the thickness, the process and the product needs to be heated. So the water is getting out of that paste recipe. And then after the evaporating, it gets to the calendering. The calendering is actually pressing together the paste and the copper band. So they need to reduce the thickness of the foil, and then it's actually slitting. So they're cutting this foil into different pieces. After that, they stack the foil, and they also have a separator foil. So it's more like a stacking process. Then it gets packaged together. And then there's coming some air inside, which does some chemical processes within. So we have then one bag, which is then also again stacked together. Then there's a formation and aging process. So that needs to be sit down and age a little bit. And then actually in the end, it needs to be storaged. And then it's basically done for sure. That process is also going to vary from producer to producer, but that's overall the process we are actually talking at the moment. And as we see, there are a lot of processes which have a high energy demand. So let's just look at two processes. So that's a heating process. I said that it's drying. So after the coating, it gets to a drying line. Actually, it can be up to 70 meters. And there are 4 chambers with different temperatures between 80 and 130. And this temperature is not going down, going up. So it needs to be a steady temperature. So you see the energy consumption of that actually heating process is already so high that you already need to see and not need to think about where is the air actually going from this process. So you have exhausting air. Do you want to reprocess this? Do you want to recycle the air and getting it back? And there's also the building automation coming in place. So that's not a process which is just sitting there and you have one measurement you can measure, and then you have your energy monitoring. It's actually measuring different parameters of this process. As well, after the heating process, there's coming this calendering process, which needs high pressure. It's up to 300 tons actually to get the foil down to a thickness of 0.004 millimeter. And that needs a lot of energy as well. And if you just look at this process, there are different types of process in one process. So that's also not just one parameter you measure. That's like a line in one machine, kind of, and that makes also the complexity if you think about the quality processes. So you can also, with the energy and the temperature, already have some looks at the quality of the cell. And that's why also this customer decided to not just go with one use case, the energy monitoring use case. So they also went and first saw just about energy monitoring, and then also included building automation. And then the third point I want to highlight is the potential savings through new processes. They already have some new process in place which they calculated, and if they get this new process on board, and that's also, when you think about that, you need to have a flexibility also with the data flow, the data architecture, with other use cases, like do you need maybe new endpoints, new data from other machines. And they calculated that they can reduce the factory space by 50%, and they will have 30% less energy consumption. And also the race production would be reduced by 13%, and they would have 15% less CO2 emission. And then that would save them more than 100 million actually annually, just to have a new process in place. And that's also very important for these companies, the better said companies, because they will have a lot of change during the next year because of the technological change as well. So as I said, the customer was coming from the energy management case, put in building automation as well, and then decided just to go away from this gateway for gateway solution. So having a gateway for energy management, having a gateway for building automation, and then having another gateway for the cloud. They just said they want to have one gateway over the whole production, over the whole use cases when it comes to data, and they want to have a solid data infrastructure and a digital backbone, which we provided. So what did this companies actually did different? And now you would think how actually to start. So that might be familiar with you. That's actually, you need the right team first. So build a cross-functional team, not just one department. It needs the IT for the data governance and the security. It needs the OT to have like this machine sensor knowledge, like how that works, which data they already maybe need from machines to get these use cases. And then it's also the business owner, which have the data demand already. You can go up to the controlling, and then as well, like if you need to comply with ISO regulations, you also need data for that if you get audited, for instance. Then, as we saw in the first example, it's also you not just build a case without a business value, right? So for that, we also need to calculate the business value actually of what energy monitoring, or what actually brings a data infrastructure maybe to your company, and how is that actually coming in numbers. So we have a lot of we have cost savings, we have reduced downtime, we have efficiency improvements, you can reduce waste, and then you also, as we saw already, you can lower the CO2 emissions. As well, if you choose the right digital backbone, and that's what I said and what I mentioned in the second example, you start maybe with one use case, but already within your company, there are more use cases maybe on a piece of paper. If you have a cross-functional team and you get these use cases, and then you do the right first step, maybe also doing the energy monitoring as a first use case, but you have in mind that you want to scale this use cases. You don't want to end up in like this pilot purgatory where you have pilot by pilot or use case by use case, but not thinking about actually if you can connect the use cases. And if you start at every use case at the same point again, you will have not only a lot of costs for every use case, you will also end up losing time. That's why we also know that with a digital backbone and data infrastructure, there's a possibility after the first use case to scale the next use cases really fast and get these use cases, because you already have the data from the shop floor, maybe from the machines, from the sensors, and you can use that data in your next use cases really fast. And that brings you to a fast scaling of your use cases and a reducing of time, as you see in this little diagram on the right. So how does that work? As we already saw, you have maybe a business demand. There's a regulation coming up, like the Energieeffizienzgesetz, or just you want to save cost. We have the energy management use case. This energy management use case needs some data from the OT, so machines or as well sensors, could be building automation as well, as we said. But we also know that most of the time there are more use cases, there are more systems which needs to be connected, like cloud, ERP, and MES system to get the right data to the right point. But it would be nice when we have just straight lines in the production and the data flow would be just straight. But normally we see something like this. So we have a lot of data flowing from different machines to different systems, and as you see, that's quite messy sometimes, and that's where Connectware comes in place. With our product, we see that we can actually get away this complexity between the shop floor and the IT systems by just having one layer, one data infrastructure, one digital backbone, which then kind of creates the straight lines, because getting the data from the shop floor and sending it to the right systems. I just jumped to the next one, and that's actually how our customers use most of the time the Connectware. So we have in the Connectware, we have the protocol mapper, which is taking care of the conversion of the protocols of the sensor data. Then we have a strong rule engine. We have an MQTT broker inside the CybusMQ, which is scalable. So the whole Connectware is scalable on Kubernetes, also with high data load. If you think about battery manufacturing or also automotive manufacturing, you have a high load of data which needs to be processed, and therefore we can scale the Connectware on Kubernetes. Configured is the Connectware via commissioning file. These commissioning files are YAML files, text-based, so pretty easy if you have some IT knowledge and some programming skills. You can store this in your repositories, and then out of the cloud or on premise, use a CI/CD pipeline to get this commissioning files to the Connectware on premise. So Connectware is running on premise, but you can store the commissioning files also in your Git repository, let's say in the cloud. As well, from the CI/CD pipeline, you will probably deploy it on your one plant. But as we saw in the first example, with more than 100 plants, you might think about the scalability. And if you have templates in commissioning files, you can pretty fast roll out that to your other plants in your factory network. If you have more questions, you can sure shoot us a message. So I would just go over to the last slide. What's worth remembering, as we talked about it, set up a collaborative team, calculate your business value, choose the right scalable digital backbone, and then embrace the strategic decisions and think about the long-term transformation. Yes. So as I said in the beginning, we are actually next week on the HMI. Also, Lucas will be there, I hope. So with us in the hall 15, stand B02. And then I just thank you all for being here, for giving me your audience. And then, that's me, Benjamin Gehlken. You can also contact me or one of my colleagues. Thank you.
Thank you, Benjamin. So we are open for your questions. And in the meantime, let me just quickly pop here our Hanover Fair link. So if you want to already book a meeting with one of our industry leaders, please feel free to do so, or just meet us on site throughout the week. We will be happy to welcome you at our booth. So we have one question. I think Benno already answered this a bit, but here is one question that got in. How do you get the scalability of use case done through your software? Maybe you can quickly explain this.
Yeah, that's actually done through two things, I would say. The YAML files and the configuration files, you can have templates, you can version them, you can store them, and then also you can reuse them. So you can actually, take this as an example, and then, you see it on the left side, and then you can also deploy it pretty fast to your other plants. So just reuse it, and then within a factory, the scaling, that's also the same principle. I would say you have a service commissioning file in the YAML format, and then you might have an S7 PLC, or you have an OPC UA protocol. Then you can just take out the OPC UA, remove it with the S7, but the commissioning file stays the same. And then you can also have the scaling through like parameterize the different IP addresses of the machines, of the PLCs. And then with tools like Ansible, actually, automation tools like Ansible deploy that pretty fast, pretty easy. Where we do it actually at every customer. They most of the time use the CI/CD pipeline together with an automation tool like Ansible, and then deploy it to their factories or to their factory network.
Yeah. All righty. So one other question that we got, maybe you can get into this also a bit deeper. Can you accumulate the data from different sources and send them to one system, maybe?
Yeah, perfect. I think this, the slide shows it the best, probably. We have this protocol mapper, and this protocol mapper gets the data from the sources, so from machines, from sensors, and then you can actually, with our rule engine, accumulate data, you can aggregate data, you can probably also get data from an ERP system, from an MES system, process and aggregate it with shop floor data, and then send it to your energy management system, or send it in the cloud, or wherever you want to have this. So definitely with our powerful rule engine, that's possible, and also the connectivity which comes actually out of the box with most of the industry protocols. That's pretty also one big advantage of the connector.
Okay, and last question so far coming in. How should I plan with the help of Cybus connector between our OT and IT departments to get ESG compliant with all my facilities?
Okay, yeah. So as we said, that's also all about collaboration. You just not have like one OT or like an OT team doing the transformation or doing the energy use case. You don't have just one business user who is driving that. It needs to be a collaborative team between IT and OT, and then they need to think about like what I said about the different steps they want to fulfill, and then that's basically what I would say. Getting together these departments, having maybe a first meeting, and then evaluate how they see also the data flow in their production, and then how they want to also scale the use cases. Because I think as in the past, we have seen a lot of pilots, a lot of little use cases on one machine, but we need to think about scaling that to have like a real smart factory, and that's what Connectware is actually for.
Thank you, Benjamin. So no further questions popped in here. So maybe you want to save your questions to meet us live and in person at the Hanover Fair if you're there, or you can also reach out to us afterwards, direct message to Benjamin or through our website. Feel free to do so. Thank you, Benjamin, for jumping in at such a short notice. Great job. And have a good day, everybody, and see you next time. Bye-bye.
Thank you. Bye.